This video intends to give a very basic idea about power quality, and this is part 1 of our series on power quality. Power quality study. We are hearing a lot about power quality study and specifically harmonics analysis nowadays. What is this all about? Why does the term need attention? Whether present power quality monitoring levels see any further scope of improvement? What is power quality? There are many definitions provided by institutions like IEEE, IEC, EN, and IS. We consider power is a function of two variables. Those are interdependent as well. Two variables are voltage and current. So we can say power is a function of V and I. So it is very logical to understand that power shall be considered good when its variable falls in a range of acceptable values. Above mentioned institutions have studied and provided this range of acceptable values. Further, we can say that any of these two variables is not in the range, total power quality shall be considered as a bad power and require attention. We would like to elaborate for stating any of two, since we know any disturbance in a voltage will reflect in a current and vice versa. However, we must conclude for a disturbing variable, whether it is voltage or a current, an affected variable. Things can be more complicated when both variables contribute at the same instance of power delivery. When we can conclude above, we would be able to define the possible quality of plant's electrical environment. Now, why does the term need attention? Power demand is increasing day by day, and this in turn challenges the power system stability. With the advancement in technology, interrelation between V and I no longer remains linear, and this makes power system engineers' job more challenging. Today, technology requires fastest and accurate response, thus making equipment more sensitive which work in a very small range of acceptable values of voltage and current, and this making equipment designers job very critical. Now it is logical to understand that without knowledge of coordination between supply and equipment, failures, maybe short term or long term, are expected to occur without any pre-indications. Now here comes the importance of monitoring voltage and current of a plant to understand compatibility levels between supply and equipment. So it can be rewritten as need of power quality study is to ascertain failure modes of equipment and risk assessment associated with it. To provide equipment designers a basic electrical conditions to achieve most economical viable service life of equipment. You can say this can be considered as equipment compatibility. To take corrective actions to improve existing power quality of power system so that already installed equipment gets a specified electrical conditions. Finally, to see if the maintenance strategies can help. Now, whether present power quality monitoring level see any further scope of improvement? Here, maintenance team must understand monitoring levels in respect to number of monitoring parameters that they get, such as voltage, current, power factor, apparent power, reactive power, kilowatt, kVA, kVAR. The second one that should be seen is that number of data points they get in a specified time intervals, such as you get a data for every second times, you get a data for a minute intervals, you get a data for a 5 minutes or 10 minutes interval. Third one is the type of information about V and I, voltage and current, such as what is the harmonic content, whether we are getting a true RMS value or it is just an average value or a RMS value. What is the values that we are able to obtain, that is maximum minimum values. Then voltage regulation, whether we can arrive on a calculation of voltage regulation. Can we get the crest factor, can we get the K factor, can we capture the sag and swells, because the time that sag and swell occurs is a very small short time, that is in milliseconds, whether we are able to capture the interruptions as well. So after this, a team must arrive to a conclusion whether any further improved monitoring required, specifically with respect to time and accuracy, because this will only can help us finding out any root cause analysis for any failure of equipment, or any other things that equipment manufacturer tells us and we can give them. Now I will show you how does this monitoring is done. Now we will show you a few monitoring samples that is captured with this meter that we have shown earlier. Now if you can see here, this is a voltage graph wherein this is the trend over 13 hours of time. So 13 hours, if you monitor a plant, these things you will get. Now here there are very sharp dips in a voltage is seen. So here there was a starting of high inertia motors. So because of these motors were started on this particular time, there was a sharp dip occurred. Here you get a values of average, minimum, maximum for a period of this 13 hours. Here this graph shows capacitor switching transients. Now this you can see the load is in kiloampere. The load is very smooth, but as soon as there is a switching in the capacitor happened, it took a very high rise in a current, and at the same time you can see the problems in the voltage. Now these sharp dips can impact a sensitive equipment like electronics, blast, or a lot of electronic things. Here this is a case of parallel resonance phenomena when capacitors are installed. You can very well see this is a capacitor off region, this is a capacitor on region, and there is an amplification in the particular harmonics. So if you can see fifth harmonics in the capacitor off region, it was in the range of 100, but as soon as you make the capacitor on, it rises up. However, 13th harmonics reduces. So this kind of information that we can get, and then we can provide a solution for this kind of stuff. Now when this kind of parallel resonance happens, you see a very high harmonic currents flowing through the capacitor, and this will damage your capacitors very soon. So premature failure of a capacitors can happen, but this can be prevented if you monitor it at a very early stage. Prasad Gore, lead strategy, techno commercial engagement and technical writer at Electrical Science Solutions. You can share your concerns at prasad@electricalsciencesolutions.com. Thank you very much.